The Tru-Image has been designed for ease of use and versatility, and offers significant time reduction compared to measurements with traditional spot-based systems. This 2D imaging solution helps reduce significantly measurement times relative to traditional spot-based instruments. We will not have an opportunity in this video to show every detail of the hardware and software, so we'll learn how to set up for a measurement, make the measurement, and display the results as tabular and graphical formats. Finally, we'll wrap up with a lesson on generating a PDF report utilizing the measured data. For complete information, please see the Quick Start Guide or instruction manual. For the purposes of this video, we are assuming that you have installed VideoWin software and have the camera and software running. To make sure that the measurements we make give us the best results, it's important to check and, if necessary, modify parameters that affect the way these measurements are made. Click on Camera and then Setup. Once in the Setup dialog, make sure that the lens that is actually on the camera is the one selected in the lens field. If you are not using an ND filter, make sure the ND field says Open, or make sure the selection agrees with the ND filter that you are using. Is the sample operating at frequency? Enter it in the Target Frequency field. You can use any photo research spectroradiometer, such as the PR6 or PR7 series, to measure frequency. Optimization defines the way the camera decides how long to make the measurement for. Make sure that this box is checked. To optimize on a specific part of an image, click on Optimize on AOR and Show Rectangle. Finally, make sure that the correct color matrix calibration factors will be used following the measurement by selecting it in the Color Matrix Converter field. Like any camera, sharp focus is important for the best picture. The Tru-8 is no different. It's critical for achieving the best measurement results. To focus the camera, click on Camera, then Focus Mode. The focus window appears. Aim the camera at the area of interest and slowly adjust the lens focus ring until the image is in sharp focus. You can use the vertical violet slider on the right side of the window as a focusing aid. The higher the bar, the better the focus. When the best focus has been achieved, click on Stop Focus. A window will appear asking for the focus position. The focus position is found on the objective lens on the focus position ring. Enter the value of the indicator that aligns with the reference point in the focus position window. We've set up and focused the camera, so now it's time to capture an image. Click on the capture icon. The camera is now capturing through each of the 3 color filters. Note the exposure time status bar in the lower left-hand corner. Blue is underexposed, green is acceptable exposure, and red is overexposed. After the capture, VideoWin populates the screen with the captured image in the image window, a CIE chromaticity chart in the graph window, and the tabular data in the data view window. All the windows have associated toolbars and options, which we will learn a little more about as we progress. As a default, a composite color image is presented. If we want to view it as a grayscale or pseudo color map, simply access the Select Bitmap Types drop-down menu and make the selection. The pseudo-color view gives us a convenient method of judging uniformity based on a color assigned to a luminance range. Point at a color in the color legend to see the luminance range of that color. These values can be reassigned in the pseudo-color settings menu. Click on View, then Pseudo-color settings. Luminance values can be individually assigned, or an auto-range feature automatically assigns luminance based on the entire image or a selected AOR. Note how pointing to the color scale displays the luminance range for any given color. Analyzing the measured image for luminance and color is the reason we made the measurement in the first place. To accomplish this, we need to define what part of the image is to be analyzed. It can range from the entire image to just a few millimeters. Defining areas of regard, or AORs, is how VideoWin determines areas to analyze. First, zoom in using the magnifying tool and then select the rectangular AOR tool and place the cursor on the area you want to enlarge and left mouse click. 3 basic shapes are available: rectangles or squares, ellipses, circles, and polygons or multi-sided. To draw an AOR, Click on the shape in the Tools window and then in the image. Click and drag until the desired shape is formed. You can also reposition the shape. Once satisfied, right mouse click to lock the shape. We will draw a rectangular, then circular, and finally a polygon AOR. The calculated values instantly appear in the data view. If you want to modify the shape or change the position, simply click on the Modify Selection icon. The selected AOR can then be edited and moved. A cloning tool makes it easy to recreate a given AOR shape over and over. Simply click on the cloning tool, press Alt, then left mouse click, point to another area, click again, and the AOR is recreated. AORs can be grouped, an easy method for quickly getting average luminance and color values from multiple AORs. Just click the group icon. Draw an AOR around a selection of existing AORs and right mouse click. The group is created in the data displayed in the data view. If you need a little extra help manipulating AORs, Context Help is available in the lower left-hand corner of the Video Win screen. To clear all AORs, click on the Clear All AORs icon. We've captured an image and defined the areas of interest to analyze. Now it's time to take a look at the calculated results. The tabular data associated with AORs is found at the bottom of the Video Win screen and is presented in a spreadsheet format. If you don't see the data you need, the spreadsheet can be customized to display whatever values are important to you. Simply click on Options, then select Columns. In the list that appears, check or uncheck the appropriate columns to create the exact view that you want. To use the Tru-8 as a go, no-go tool, pass-fail criteria can be set and then displayed in the data view. Click on CIE in the graph window, then Options, then set pass-fail regions. Do you want plus and minus tolerances to be the same value? Select this in the tolerance mode. Do you want to test the average value of a shape, all of the points in a 3-point character average, or the average result of a 3-point character average? You can make this selection in the Check Mode section. Are you checking pass-fail information for luminance or color, or both? Check the appropriate boxes in the Check Type column. Enter the target values and tolerances in the appropriate boxes. Lastly, don't forget to select Fails as a data column. As you can see in the example, luminance Y has failed. They say a picture is worth 1,000 words, and to that end, Video Win 3 has several graph views to help visualize measurement results. First, and probably most used, is the CIE diagram. Click on CIE in the graph window. The default view is the CIE 1931 XY chromaticity diagram. Other options include the CIE 1960 UV space and CIE 1976 uniform color space. If you have set up pass-fail criteria, click on the pass-fail zoom icon to enlarge the pass-fail region. To get a picture of luminance performance, Video Win gives you the ability to view luminance as a histogram 2D or in a 3D presentation. Click on Luminance, and a histogram of all AORs or the selected AOR replaces the CIE diagram. Click on the Select Chart Type icon and switch to 3D. The plot shows XY pixel location versus luminance in the Z-axis. The plot can be manipulated and enlarged or reduced. For both the histogram and 3D plots, a color legend with associated luminance values provides intensity information. Do you need to submit a report to your boss or customer after the work is done? Use the built-in report generator. Click on File Report to access the report dialog. Fill in the information including part model and serial number, company name and logo, information about the test and tester, the pass or fail status, and graphs including the image with AORs. It can even include different graph views such as 3D luminance plot, 3D chromaticity delta, and line profile. For more information on all photo research products, be sure to visit our website at photoresearch.com.